Okay, so now let's revisit. We're going to slowly start talking about adding and subtracting rational expressions without the same denominator. And so we need to spend some time talking about how to find a common denominator, preferably the lowest common denominator. So again, the idea is if I have a couple of fractions and the denominators aren't the same, that means my pieces are different with pieces, and so it's kind of hard to match up, how many pieces add up with this and how many subtract away from that. So we need a common denominator. We need our pictures to look at least the pieces of our parts to be broken up into the same pieces. So this obviously has that first problem. So how do we find the LCD? Well, first of all, remember what LCD is. It's a number that both 12 divides into nice cleanly and 30 divides into cleanly. So it's a number that's going to be bigger than 12 and probably bigger than 30. So what number, right, does 30 go into cleanly and what 12 goes into cleanly? Some people sometimes call us the lowest common multiple, right, because that's literally what we're finding there. So what number is both divisible by 12 and 30? Well, of course, one of the most common tricks we kind of do, right, is some students just simply multiply the two together, right? That'll at least find a common denominator, and this will get really big, right? So if I do some work here, what we get is 60 and 30, so 360. So that 360 is an LCD, but it's huge. All right, those are some big numbers to be walking around and all that. So it's probably not a really good way to do that, especially when you look at what's coming. All right, to find a common denominator, perhaps multiplying the two that I have isn't really an economical way to do an LCD. So how do we do that? Well, another trick that we learned way back in the day was to just take 12 and start listing multiples of them, right? And then figuring out eventually which multiple, right, has 30, right? So 12 is not divisible by 30, 24 is not divisible by 30, 36 isn't divisible by 30, right? That gives us 48, which isn't, and then we have 12 times 5, which is 60, and then boom, we found it. So right now, not only did I find something that's common, but 60, right, is both divisible by 12 and it's divisible by 30. So there's our LCD. There's the guy that's common to each. And then we can go through our equivalent fraction work and get to business. All right. However, right, let's take again a look at where we're heading. Right, you eventually have to find the common denominator between x squared plus x minus 6 and x squared minus 9. So what do you start multiplying the x squared minus 9 to figure out what that guy's divisible to? Right? If you guys can figure that out, you're geniuses. Right? Because it's really hard to do. This trick right here only works if I have nice, neat numbers to work with. Because I know what it means to multiply 12 by 1 and 12 by 2 and 12 by 3. But what do I multiply x squared minus 9 to find the same common denominator for x squared plus x minus 6? It's impossible. So let's go back here and figure out, is there a way that we can still find that the LCD is 60, but that method will help me find the LCD for these guys? And it turns out that what we use is prime factorization. Here's an old friend from way back in the past. What we begin to do is we take 12 and we start breaking it up into its prime factors. So for starters, that's 3 times 4, and that's 3 times 2 times 2. So there's the prime factorization of 12. So the idea we're going to use eventually is the fact that the number we're looking for has to have 3 and 2 and 2 as its common factors, right? Because 12 needs to go into that number. And then we do the same thing for 30. So 30 is 5 times 6, and then that breaks down into 5 times 3 times 2. So there's the prime factorization of 30. Okay? So what we're trying to do is find a number that bridges both of those two ideas together. So 3 times 2 times 2 has to be a part of the LCD, and 5 times 3 times 2 also has to be a part of the LCD. So what number can I put together that has both? All right, and I kind of want you guys to think a little bit about biology. We're all adults here, so hang with me. Right? It's almost like the LCD is an offspring. Right? It's a son or a daughter of mom and dad. All right, and so the way biology works is the offspring, right? We as children get a little bit of DNA from our mom, and we get a little bit of DNA from our dad. And they kind of mix and they match, and what creates is you. And so that's what an LCD is. It's kind of an offspring of mom and dad. So everything begins with mom, right? The LCD has to have a 3 and a 2 and a 2 in it. It's got to have those in there, right? Because we want mom to be in there. And then we're going to take a look at dad. So what does dad want to offer? Well, he wants to offer a 2. But mom's already got it covered. She has 2 of them. So we don't need dad's 2, right? Dad wants to offer a 3. But we already have a 3, right? Mom's already got him covered. So we don't need that 3. But one thing that dad has that mom doesn't have is that 5. So I need to tack on that 5. And lo and behold, when you multiply all this together, right, 3 times 2 is 6, 2 times 5 is 10, 6 times 10 is 60. And there is your LCD. So the idea to find it is we find the prime factorization of one number, find the prime factorization of the other, always start with the prime factorization in your LCD, and then kind of mix and match what's missing with the other one. Right? So let me do that one more time. Let's say we had something like 5 over 18, and I want to add to this, let's say 3 over 12. Right? So what's the LCD of that? Again, you could use this trick, but using the prime factorization, right, 12, we already know breaks down into 3 times 2 times 2. 18, well, that's 2 times 9, and that's 2 times 3 times 3. So there's the 2 prime factorizations. So what's the LCD? Well, let's start with mom, right? For sure, we have to have a 3, a 2, and a 2 in it. So what about dad? Well, dad wants to contribute a 2. We've got 2 of them, don't need it. Dad wants to contribute 2 3s, and right now only have 1. So what's dad going to contribute? He's going to contribute 1 more 3. And if we multiply this together, 6 times 6, what we get is an LCD of 36. And I think you can readily available, right? 12 goes into 36 3 times, and 18 goes into 36 2 times. All right, and again, you see there's mom, right? There's 12, and let me take away a 2 there, and there's dad, right? There's the 18. As a matter of fact, I forgot to show that here, right? So there's mom. 3 times 2 times 2 is 12, and let me take away 2. There's dad, right? 3 times 2 times 5 is 30. So this prime factorization trick to build the LCD, and believe it or not, that's what we want to do these harder examples that are coming up, and I'll get them in a moment. You'll see those in the next video. So prime factorization, factoring, comes into play.